All right, this is an incomplete dominance question from page 29, question 2. You'll know it's an incomplete dominance question if either the words incompletely dominant appear somewhere in the reading of the question, or if we see three phenotypes where one is a blend of the other two. When you find that one, make that one the heterozygote. All right, so when we look at this question, in a certain strain of chickens, a mating between a black chicken and a white chicken always produces offspring which have a distinctive feather appearance called a blue. Wait a minute, blue. I've got black, I've got white, and I've got blue. There's black, white, and blue. This would work a whole lot better if this was black, white, and gray, but for the purposes of this question, we can just imagine that if black and white mate, we might find that blue is in fact the blend of those other two. In that case, we're going to use letters like that for black, maybe W's for white, and therefore the heterozygous BW would mean blue. That's probably the hardest part of this whole question. So this, pardon me, this is our legend. So let me just shrink that up. I'm going to take all of this and shrink that up as well and make some room for us here. Thanks. Move it over. There we go. Move this over. So using Punnett squares to illustrate the two crosses above. So if we have a black chicken mating with a white chicken, are we always going to produce blue? Well, using this as our legend, I'm just going to imagine that there's a sign for a male. We're just going to pretend that there's the black one. And it doesn't say which one is male and female. That doesn't matter in this sense, in this case. But let's set up our Punnett square. It's an X and O board inside a box. I'm going to put one parent out there. I'm going to put the other parent right there. Clearly, we know that through meiosis, gametes are produced. And here we can see that we have nothing but B's and W's coming together. And when I look at this, I compare what we have here inside the offspring boxes with what we have as the legend. And I find that since all four, or 100% of my F1 offspring are BW, they will all be, check up there, blue. All blue. So let this continue. I'm just going to take that away. Maybe. And I'm going to keep this. Oh, wow. Special right there. And I'll try the second cross. The second cross begins right there. A cross between two blues produces blue, black and white. Let's see if this is in fact true. I'm going to take two of the blues from right there, one there, and one there. Let me just erase some of that stuff out of the way so that I can show B, W, B, W separating in meiosis, and we end up with big B, big B. That appears to be, check our, right there, our legend. We've got some black appearing. We've got B, W, B, W. There are the blues. I like that I used red ink for the blues. And W, W. Again, check right there. And we can see that we've got the whites already taken care of. So there are the two crosses illustrated as requested by the question.